The moon has had a profound impact on the Earth ever since it formed about 4.5 billion years ago. After a planet collided with the Earth, it has shaped the entire evolutionary process of our planet. Since then, the moon has been orbiting around us. It exerts gravitational pull on the oceans, causing the tides to rise and fall. You could even say that it played a role in the birth of life. So, what would happen if we blew up the moon with nuclear bombs? Well, blowing up the moon would bring some terrifying consequences to our planet. Kind of like what happened in the movie Oblivion, where the aliens believed that the best way to wipe out humans was to destroy the moon. You might not know this, but both Russia and the United States had plans to bomb the moon back in the day. The political and cultural tensions between the US and Russia at that time made such desperate plans seem somewhat reasonable. In 1958, under the guidance of the US Air Force, the Armor Research Foundation developed a plan to bomb the moon with nuclear bombs. Supposedly, the plan was to study the possibility of conducting a nuclear explosion on the moon's surface and ultimately evaluate the effectiveness of nuclear weapons in space. In fact, both sides wanted to detonate nuclear weapons on the moon's surface at that time to show off their strength. If Carl Sagan hadn't been involved in a classified project to detonate a nuclear device on the moon, we probably wouldn't even know about these things. Russia also had its own plan called Project E. Of course, none of these plans were actually carried out in the end. Instead, we sent probes to the moon later. So, the idea of bombing the moon isn't exactly new. The question is, why would anyone want to bomb the moon? And what would happen if we could actually do it? Most of you probably already know that we don't have the technology to blow up the moon at all, even if we used all the nuclear weapons we have now. The worst case scenario would probably be that the moon would be blown into some smaller pieces, and then eventually these pieces would come back together again. But then, it would look very different in the night sky. But let's just imagine for a moment that we had the ability. As for why someone would want to bomb the moon, that's $1 million question. Losing the moon wouldn't have any positive effects on our planet. In fact, the role of the moon is more than you can imagine. It turns out that the moon's role isn't just to provide light for us at night. The impact craters on the moon show that our lunar satellite has taken the hits from some asteroids that could have otherwise hit the Earth. Even if the Earth could survive the impact of the moon being blown up, other space meteorites might now hit the Earth. But that's just the beginning. Different ways of blowing up the moon, and different directions of the fragments flying around, would all bring a lot of negative effects to the Earth. Blowing up the moon would create about 7 times 10 superscript 2 superscript 2 kilograms of fragments. These fragments wouldn't hit the Earth in large chunks. But since the moon is pretty close to the Earth, it's certain that a lot of fragments would hit our planet. You might be wondering, how many nuclear bombs would it take to blow up the moon's surface? According to some professional online tools estimations, if we were to use nuclear weapons to blow up the moon, we'd need around 9,015 1-megaton nuclear bombs. If that many nuclear bombs exploded at the same time, there would be large pieces of the moon flying around in space, and a lot of them would come straight towards the Earth. Chances are, many of these fragments would be big enough to cause major disasters and hit the continents. When the moon explodes, the rock fragments would rain down on the Earth. Some of these fragments might take a few days to reach our planet. As they come speeding towards the Earth, it's safe to say that most of the damage on Earth would come from the debris of the moon. Rock fragments don't need to be huge to cause massive destruction. Just think about the Chelyabinsk meteor. Because it was blocked by the sun, it wasn't detected when it entered the Earth's atmosphere. That meteor was 20 meters in diameter and weighed between 12,000 and 13,000 tons. The object exploded in the air at about 97,000 feet. The explosion produced a flash brighter than the sun. Witnesses said there was intense heat, seismic waves, and energy that could be measured by infrared and acoustic means. It's estimated that the explosion was equivalent to 400,000 to 500,000 tons of TNT, which is 26 to 33 times the energy released by the Hiroshima atomic bomb. Even though most of the object's energy was absorbed by the atmosphere, 15,500 people were still injured, mainly from the flying glass fragments shattered by the shock wave. And the shockwave also damaged 7,200 buildings in 6 cities in the area. Now imagine hundreds of such impacts happening over a few days or months. The destruction would be truly staggering. Humans would have to take shelter underground. A large number of rocks and fragments would heat up and burn as they entered the Earth's atmosphere, which in turn would quickly heat up the atmosphere and turn the Earth into a giant oven. This kind of destruction doesn't even include the impact of those huge fragments that might be several kilometers long hitting the Earth, not to mention the other small fragments that hit the upper atmosphere and raise the Earth's temperature. There would be a cloud of dust formed, which might block out the sky. Except for the fireballs formed by the lunar objects entering the atmosphere, all light would be blocked. And while all this destruction is happening, there's something even worse coming. They would change the Earth forever. The disappearance of the moon would affect the Earth's orbit, rotation, and wobble. The moon acts like a stabilizer. Without its stabilizing effect, the Earth's wobble would become more and more severe. The 4 seasons as we know them would cease to exist, because the Earth would orbit the Sun in an unstoppable and unstable way. The Earth might eventually wobble violently and could even tilt completely when it rotates, lying on its side relative to the Sun's orbit. This would lead to extreme differences in temperature and day length. At other times, the Earth would be completely vertical, making the day and night lengths equal throughout the year. There would be no more 4 seasons, and there would be periods of extreme weather. The temperature difference between summer and winter would become even greater, thanks to the moon we have now. The Earth's axis is tilted at an angle between 23 and 26 degrees. And it's been like this for millions of years. Compared to now, the tides would become much smaller and the oceans would be much calmer, because the tides are mainly pulled by the moon's gravity right now. Although the sun is 400 times the diameter of the moon, it's also 400 times farther away from the Earth. At the sun's distance, its gravitational pull on the tides is only 40% of the moon's gravitational pull on the Earth's oceans. When the sun and the moon are in a straight line, the spring tides are 140% of the normal tides. But now without the moon, the tidal patterns would become much simpler. The marine life we know would disappear, because most of these organisms would die without the tides. If we suddenly removed the moon, there might be huge tidal waves, because the moon's gravity would suddenly disappear. On the other hand, if we decided to use something like the Death Star weapon to blow up the moon, we might be able to avoid some damage in the first few years, until the Earth's wobble made us feel the impact of the moon's absence. Without the moon, the length of a day on Earth would be much shorter at times, averaging around 6 to 8 hours long. 4 billion years ago, because the moon was closer to the Earth back then, a day might have been only 8 hours long. That would make a year have around 1,100 to 1,400 days. And our days are much longer now, because the tidal friction caused by the moon has slowed down the Earth's rotation speed. In fact, more than 4 billion years ago, the Earth's rotation speed was about 3 to 4 times faster than it is now. Currently, the moon's gravity slows down the Earth's rotation through an effect called tidal braking, making our day length increase by 2.3 milliseconds every century. Meanwhile, the moon moves 40 centimeters away from the Earth every year, which is how we have our 24-hour day now. There would be a lot of dust and small rock fragments, forming a ring system around the Earth, just like Saturn. Over time, many of the moon's fragments would break away from their orbits due to the influence of the Earth's atmosphere, and cause a series of impacts. But in the night sky, there would be a gray halo made of lunar dust around the Earth. Without the moon, the night sky would be much darker. In the middle of the desert, a full moon can create some of the most amazing starry sky scenes in the Milky Way. On a dark night away from city lights, you can even see the disk of the Milky Way clearly. And the moon actually reflects a lot of sunlight, and is the brightest object in our current night sky. Without the moon to light it up, everything would be pitch black at night. Venus is the second brightest object in the night sky, but its brightness is only 1/14 of a full moon. Also, the sun will still shine on us as always, but there will be no more lunar eclipses or solar eclipses. That's all for today. If you liked this show, please give it a thumbs up and subscribe, so you can get more shows in the next episode. Thanks for watching.